What's up, guys? Welcome back to part 5 of these videos whereby I'm solving for x. This one is similar to part 4. If you haven't watched part 4, well, this is similar to it. You can go back and watch it. By the end of this video, there is a playlist whereby I show the videos that are within that playlist, so you can go and click on that video at the end of this on that playlist at the end of this video, so that you can watch the videos in sequence. Anyway, guys, so last time we were solving for x and we have a problem that which is very similar to this one. So guys, when you come across this type of equation, as you can see here, we have sine 2x is equaling to cos half x over 2 in fact. So as you can see, they're actually identities. So the logical thing to do here is to change this into identities, but this can drag, can take long, and this problem here, guys, is very simple. Remember, I did mention on the last video that when you come across this type of a problem whereby on the left hand side you have a trigonometric ratio and the right hand side you also have a trigonometric ratio, you look at the relationship of those trigonometric ratios, and if they do have a relationship, in this case, which they do, sine is a co-ratio of cos. And another thing that you should pay attention to is when you don't have a constant. What do I mean by constant? Is the constant probably a number, maybe there's no plus 1, minus 2, plus 3, that is on its own. So if there is no such, and it's purely two co-ratios which are equating to each other, or they are minusing each other or adding each other, then that is enough. You can use the following steps. Now, in order for you to answer this one, again, you need to know the co-ratio rule. So I did make a video about the co-ratio rules, so I hope you guys will watch them. If you don't understand what I'm about to do, you should go and watch the co-ratio rule before you watch this one, because you want to understand what's happening here. So I left the video on the icon there on top, so you click on that video, watch the co-ratio rule, and watch how do we actually apply it. But then before I start, look at the restriction here. It's x cannot be less than 0 but should be greater than 0, and cannot also be greater than 90 but should be less than 90. So meaning this falls within the first quadrant. Now let me just draw our cast diagram here. Okay, so this is 0, that is 90. On the first quadrant, when we use the co-ratio rule, this is how we represent our first quadrant. So look, guys, you look at your trigonometric ratios on this question, they are both positive, so you have to change one to their co-ratios. Now I'll try to illustrate this in a simpler way. Now let me just say I'm changing the sine 2x, the one on my left. First of all, I can say this so that you can understand. This is not necessary. This is for explanation purposes. I can say let 2x equals to theta. Okay, equals to theta, and just make it 2 there. Yes, let 2x equals to theta. Oh guys, okay, let's fix our 2x. There we go. Let 2x equaling to theta. So wherever there is 2x, we put theta. So let's solve this one. Now we have sine theta, which is equaling to cos x over 2. Alright, guys, even if you don't change the other one on the x on the right, it's still fine. The aim is to explain this so that you can see what's happening here. So when you change this trigonometric ratio on our left hand side to co-ratio. Remember, we know that sine, let me just do this. We know that cos 90 minus theta is equaling to what? It's gonna equaling to positive sine, because these are the co-ratios. So you can change that one. You can change the trigonometric ratio on our left. So let's go ahead and change it. So we know that cos 90 minus theta, so it's the same as cos x over 2. Alright, so as you can see now, we have cos both sides. Now we can start dropping the co-ratios, the trigonometric ratios. So guys, I repeat again, if you don't understand how we came across this co-ratio, you need to go and watch the videos, guys. Very, very important, where I explain the co-ratios. Alright, so we drop the ratio. So let's write. So we're gonna be left with 90 minus, but we know what theta is. Theta is 2x, so we can say 2x, and then is equaling to x over 2. Do not forget, this theta here is 2x. That's why we substitute by 2x. Then from there we continue and we cross multiply, because we have on our right hand side we have x over 2, so we can multiply by 2 throughout here. So let's just do it. Okay, and we're left with x. So if you multiply by 2, this is gonna give us 180, and then this is gonna give us 4x, and that is x. Now if we transpose x to the other side, which is our right hand side, we're gonna be left with 180, which is gonna be 4x plus x. So 180 is equaling to 5x. Then from here, what do? We need to divide by 5. So when we divide by 5, it's gonna give us 36 degrees, and that is gonna be x. Guys, this is our final answer. Now let's go back to our question. If we go back to our question, as you can see there, look at the question here, guys. Look at the question here. Alright, so this question, as you can see, we don't have a constant. I repeat, there's no constant, there's no number that is on its own. That is a constant or a ratio that gives us a number, so we are good. And then we look at these ratios, they have a relationship. The relationship is co-ratio. They are co-ratio of each other. Now it's not necessary for you guys to let x equaling to theta. This is just for me to explain this for you guys so that you can understand better. Alright, so this is how you do it, people. This is how you do it. If you don't understand, you can rewatch this over and over again. If you have a better way or simpler way of solving this, you can also share in the comment section. And if this helped you guys, if this helped you to get to the final answer or to understand this type of solving for x or general solution, do not forget to like and subscribe, because there's more videos to come about solving for x and other trigonometric and other maths problems that is to do with this level. Thank you very much, guys, for watching. Until next time, cheers.